Hoving back up here because, wild animals
behind us.
So, yeah, that sounds great.
Okay. All right, equation conversion. We're going to use the things that were on the previous slide, so you may have to turn the page on your notes.
Uh-oh.
Okay? It'll be
All
okay.
right. Okay.
Or write them on the second page, something like that. We're going to convert to rectangular form.
All right, I like
There's
it.
a little bit of artistry to this.
I love artistry.
It's kind of like, I'm going to be careful about saying this, it's kind of like trig identities.
But it's not trig identities.
But it's not trig identities. The reason it's kind of like it is because once you practice the different ways, there's only so ways that they're going to show it to you. So you have to make sure and practice a whole bunch of different ways and see all of the tricks, and then go back and be like, okay, can I recognize which trick to use when? So let's do this. Convert to rectangular form. We have r equals 4 cosine theta. Now we have x equals what?
R cosine theta.
But that's not what we have. How do we get an r in front of cosine?
I know exactly what to do. Okay. Back in the old days when you took Algebra 1, you learned that whatever you did to one side, you had to do to the other.
I remember that.
And as long as you did that, everything was totally legal. Totes above board.
Yeah,
so
totes okay.
Here's how I'm going to get that r in front of the cosine. I'm going to multiply both sides by r. I know it's really weird, but this is standard operating procedure.
All right. Okay. Back up just a sec. Our goal is to get rid of the r and the theta and get x and y.
I know this is really crazy, but hang in there with me. Don't panic. Just write
r
down.
Squared.
Yep.
Oh, no, that was a bad
What was
lag.
that? That was a...
Equals.
Okay, there we go.
4r cosine theta.
Now. Shh. What are you doing?
I messed up. Just keep talking.
Okay, so we got 4r cosine theta. Okay, now 4r cosine theta matches the r cosine theta part from the x.
So let's plug it in.
So let's just r squared equals, or you could do that. Okay, 4x right there, boom. Okay, now, here's the weird thing. R squared is equal to x squared plus y squared.
Right, it's written in our notes. It's right there. It's actually probably on your unit circle as well.
Now, I'm looking at the purple line, and I don't see an r or theta anywhere.
Technically, we're done.
Technically, we are. And
you might see the book
answer could be a little different,
right? Because they are like, oh, this is some kind of like an ellipse kind of a thing, probably, and they complete the square on it. But we haven't really talked about that stuff yet, so
we're going to just hang off on that.
But
this is an acceptable answer. This is totally Cartesian rectangular.
Acceptable.
Yeah.
Yeah. Okay.
Totes acceptees.
Okay. So same deal. New problem. R equals 4 secant theta. We want to get rid of r and theta.
Multiply by r.
Secant is not something that we have something with.
It's not.
We have x equals r.
I know.
Cosine
I have a
theta.
plan. I have a plan.
Okay.
Rewrite it in sine and cosine.
Okay. I was going to point out, we have r cosine theta and r sine theta, but we don't have anything with secant. So you're saying
cosecant. So
you're saying secant is 1 over cosine.
Right, which is 4 over cosine.
Okay.
Okay. Now, here's an idea.
Okay.
You learned a long, long time ago.
A long, long time ago.
In a galaxy far, far away.
Naboo was under an attack.
Okay.
Okay. So,
but whatever you do to one side, if you do it to the other, it's totes legals.
Yeah. So we could multiply both sides.
So what we could do is multiply both sides by cosine theta, and then what happens? You keep writing, and I'm not.
You're supposed to be narrating what I'm writing. That's how this works. Have you not learned this yet? We've been doing this for a few months now.
The bears got me nervous.
Yeah, okay.
So anyway, once you multiply both sides, now you've got r cosine theta equals 4, and we know
r cosine theta
is x.
So x equals 4.
Bingo, bango, bongo.
Okay.
Chitty,
no
chitty,
r's, no thetas, done.
Dunskies.
I knew you were going to say that. Example 6, convert to polar form. Let's go backwards. Polar form, in some ways, is easier, I feel like. I feel like there's a little less technique to it, but they also can make it more challenging because what we need to do is foil.
We're going to have to foil.
Remember that x minus 3 squared is x minus 3 times x minus
3.
Because
we've got to get something where it's like
x squared,
x squared, y's, x's. Yeah, we can't have all this separation of x's and y's.
Separation of variables.
Yeah, we got. That's a story for another day.
Thing. Let's not talk about it.
That's coming about this time next year, kids.
Let's combine some like terms. For example, here,
9 and 4 and 13.
9 and 4 and 13. 9 and 4 gives us 13 on this side, but if we subtract them
A long time ago, you learned in algebra class that if you did something to one side and the other at the same time, it was totally legal.
Yes.
So...
I think that's the third time today that you've said that.
So I tried to keep a straight face.
Okay.
Subtract 13
Subtract
from
them
both
over.
sides.
Now, x squared plus y squared equals something.
Look, and there's an x squared plus y squared there. Guess what that is?
It's r squared.
Yes.
It's r squared.
You got that on the first guess.
I got it. And then x equals...
r cosine theta.
And then y equals...
r sine theta. You're writing today. What is the deal?
It's your MacBook. Don't blame me.
Jeez.
Don't blame the user. Blame the technology. Okay, now, we could leave our answer like this, but there's actually something else we could do. Because they all have an r, so you could take the r out.
What's going to happen? Are we getting ready to shake loose an r?
We are. Yeah, we're going to get rid of it.
A long time ago you learned that...
I changed that to a plus sign because I thought it was a plus sign, but this is an r.
A long time ago you learned that if you do something to one side of the equation and something to the other side at the same time, it's totes legal.
So we can divide by r on both sides.
Yeah.
And now that's not legal with rectangular coordinates.
No, it can't do it.
Polar, though, is okay.
The other thing we learned is 0 divided by whatever is totes zeros. So...
And then as long as we're going here, we could solve this for r. Because in the next section, we'll talk about graphing these bad boys.
And you want it to be r equals.
You want it to be...
Just like you want to graph y equals.
Because we're going to talk about how you can change your calculator over to polar instead of rectangular, and then it gives you, instead of having y equals, you have r equals. So we would want it solved for r like this.
Yeah.
So that would be our answer right here.
It's a good talk.
It's a good answer.
It's a good talk.
Yeah.